So the next scientist that we need now is what? Is Robert Millikan. Call it what? R.A. Millikan. So look at the Millikan discover the charge of an electron. So the contribution of what? Of Millikan is what? It discovered the charge of what? Of electron. The Millikan discover what? Charge of what? Of electron. So the charge of electron discovered by what? By Millikan by oil drop experiment. By what? Oil drop experiment. So the Lord Rutherford is the one that used what? Alpha scattered experiment to discover the nucleus of an atom, and it's also have what? His own model called planetary model. But R.A. Millikan discovered the charge of what? Of an electron. Discover what? Charge of what? Of an electron by what? Oil drop what? Experiment. That's what? Robert Millikan. And the Millikan also determined the what? The mass of an electron by using what? The charge to mass ratio of what? Of J.J. Thomson. So this man now, R.A. Millikan, Millikan, it has two what? Millikan has two contributions. What's the first one? Charge of what? Electron. So this Millikan tells us that what? The charge of an electron is what? Is 1.6 times 10 raised to the power minus 19 coulomb. Is what has given us the what? This charge of what? By oil drop experiment. And this same man also determined the what? The mass of what? Of electron. By using what? Charge to mass ratio of what? Thomson. We say that what? The charge is minus E over what? Over M equal to what? 1.76 times 10 to the power minus what? 11. This is charge to mass ratio by what? By Thomson. But from the Millikan oil drop experiment, he know that what? The charge of electron here is this. You will now have what? 1.6 times 10 raised to the power minus 19 coulomb over what? Mass of electron equal to the what? 1.76 times 10 raised to the power what? Minus 11. So from here now, make the end of the formula. You now have what? Mass of it will be what? 1.6 times 10 raised to the power minus 19, everything over what? 1.76 times 10 raised to the power what? Minus 11. So if we now divide this, now give us what? 9.1 times 10 raised to the power minus 31 kg. This is the what? Mass of what? Electron. So the Thomson perform, or it has two contributions on atomic development. Is the first one is what? It determined the what? The charge to mass what? It determined the charge of an electron, which is what? 1.6 times 10 to the power minus 19 coulomb. It's also determined the what? The mass of electron by using the what? The Thomson discovery, which is what? Charge to mass ratio. Yeah. So it will now add to what? Substitute for the what? For the charge here, which is what? 1.6, and the mass is what? Is unknown, and the charge to mass ratio where this J Thomson discover as what? 1.76 times 10 to the power minus 11. So this is it. From here, make the mass. So to the formula we get what? 9.1 times 10 to the power minus 31 kg, which is what? Mass of what? Electron. So Thomson discovered charge of an electron by oil drop experiment. I said it before. Lord Rutherford discovered what? The nucleus of an atom by alpha scattered what? Experiment or gold foil experiment. So the next scientist now, after Robert what? Millikan, that we need to check now is what? Let us look at what Moseley. He discovered atomic number. So the atomic number of an atom was discovered by what? By Moseley. So is what is a scientist that discovered what? Atomic number. And the next person is what? Let us look at what? Sam Moseley. Let us look at, yes, Michael Faraday. What is the contribution of what? Of Michael Faraday? That would be what? In 1830. So the Faraday is a scientist that discovered the electrical nature of what? Of an atom. So his own contribution is what? He discovered what? The electrical behavior or nature of what? Of an atom. And it's also have what? His own Faraday's law of what? Of electrolysis. So the scientist that discovered the electrical behavior of atom is what? Is Faraday. The person that discovered what? The atomic number is Moseley. The scientist that discovered the charge of an electron is what? Is Millikan by odd-drop experiment. The person that discovered the mass of an electron is also what? Millikan by using the what? The charge to mass ratio of J.J. Thomson. And the scientist that discovered the positive central nucleus of an atom is called what? Lord Rutherford. The person that discovered the electron is called what? Thomson. The person that discovered atomic theory is called J.J. Thomson. The person that discovered atom himself is called what? Democritus. So the next one is what? Goldstein. The Goldstein discovered the positive proton of what? Of an atom. So the proton of an atom discovered by what? By Goldstein. The nucleus of an atom discovered by what? Rutherford. This Goldstein is the one that tells us that what? Inside the nucleus, there is a particular what? Particle there called what? Proton. And the next person now here is what? We have James Chadwick. James Chadwick is this man that is complete the atomic structure. James Chadwick is the one that completes the what? Atomic structure. You know, in the atomic component, I said we have what we call what? Proton, neutron, and what? An electron. They are atomic what? Subatomic particle. So the electron discovered by what? By Thomson. The nucleus of an atom discovered by what? By Rutherford. The proton of an atom discovered by Goldstein. Where the what? The James Chadwick is the one that's discovered what? Neutron. Is the one that's complete the what? The atomic what? Structure. So James Chadwick discovered what we call what? Neutron of what? Of an atom, and in which is what? Is neutral. So, before we have talked about what? Electron. I talked about what? The nucleus. I talked about what? Proton. So the last component of attention is what? Is the what? Neutron. Who discovered by what? By James what? Chadwick. So the next scientist now that we need to check now is what? Let us look at what we call what? Nibor. Nibor experiment. Nibor, his own discovery is 1913. Its contribution is what? This Nibor introduced into what? This energy quantization. energy what? Quantization of an atom, which is what? E equal to what? HF, Planck constant and a frequency. So it's tell us that what, and it's also introduced the electronic what? Shell to us. The energy level of what? Of an electron, which is known as the what? Electronic what? Cell in form of what? Of K, L, M, N, shell. So the first person that is introduced what? The energy quantization to us in atom is what? Is Nibor. What? The energy goes to the what? H what? HF. And it's also telling us that what the electron occupy a particular energy what? Level in what? In an atom. Which the energy level is known as what? The cell notation called what? K, L, M, N shell. That is, if you have what? This kind of cell in we used to have this, that the innermost shell is called K, L, M. So this kind of energy level we have in what? In an atom, the person that introduced it to us is what? Is Nibor. And it's talk about what? The energy what? Quantization. And it's also have its own atomic what? Atomic model. So the Nibor atomic what? Model, and the Nibor atomic model, we also call it what? Bohr atomic what? Bohr atomic model. So out of all these scientists now, just four among them, they have their own what? Atomic what? Atomic model. The first scientist to have atomic model is called what? J.J. Thomson, which is model is called what? Plumb bonding model. And the second atomic model we have is what? Is Rutherford. His own model is called what? Planetary model. The electron is moving around the what? The orbit of the nucleus, or the electron is orbit the what? Or moving around the what? The orbit of what? Of nucleus at its moving around the what? The orbit of what? Of the nucleus. Called what? Planetary what? Model, as the planet moving around the what? Sun. And the third one is called what? The Bohr. Nibor introduced what? The energy quantization to us, and it tells us that what? The electron occupy a particular energy what? Level in what? In an atom. And the Nibor atomic model, you can also call it what? Nibor what? Model. So what is what? The what? Nibor model. See, the Bohr model is concentrate on two things. He said electron occupy a particular what? Space in an atom, particular what? Energy level in an atom called shell, or what? Orbital, which is what? KLM. And Bohr said what? Assume this is what? Electron that is occupy a what? A particular what? Cell or energy level in the what? In an atom. And Bohr now said what? The energy or radiation absorb or liberate when this electron is what? Is moved from one level to what? Another. Assume if this electron is what? Is coming from L to what? To K. The radiation will be what? Liberate in form of what? Of quanta. Quanta, which is what? EHF. So when electron come from higher move from L to what? To K, the energy will be what? Will be liberate. But when electron move from what? From this L to what? To M, the energy will be what? Absorb. Or radiation what? Absorb in form of what? Of this quanta. That is what? The Bohr model. The two basic Bohr model are what? The electron occupy a particular space in an atom called what? Shell. KLM shell. And the when electron move from one level to another, the radiation or energy must be what? Must be absorbed or what? Or liberate in form of what? Of quanta. Those are the ones, the basic contribution of what? Of the Bohr in atomic what? development.